Hello students, let me introduce myself. I am Dr. P. Madhusudhan, working as a associate professor in B.V. Raju Engineering College and Technology. So today I am going to discuss topic polymers classification and polymerization. So polymers unit 4, Art 22 syllabus. Under polymers we are going to discuss the topic I mentioned already. One, classification, polymers. Next, polymerization. Topic 2, thermoplastics, plastics and thermosetting resins. Example on thermoplastics. Under thermoplastics, 1, 2, preparation properties and uses of PVC, Teflon, right? And the thermosetting resins, we are going to discuss bakelite, nylon 66, right? So third important topic in chapter polymers, natural rubber, processing of natural rubber and vulcanization. Fourth topic that we are going to discuss under unit 4, polymers, synthetic rubbers. Synthetic rubbers, the topic that you have in the syllabus, SBR, thiacol rubber and butyl rubber. So last topic that we are going to discuss, conducting polymers and biodegradable polymers. These are the topics we are going to cover in under unit 4, polymers. So first topic, polymers. Definition. 1, 2, 3, 4, 5. 5 topics are there. First topic, 1, definition of polymer. So you can define in your own words what is polymer. You take simple example. Polythene. P. N number of ethylene combined under the conditions of high pressure and temperature. And formation of a bulky, lengthy product takes place. This lengthy product is called polymer. The smaller units which are involved in linking are called monomers. And the process of converting monomers into polymer under the conditions of high pressure and temperature known as polymerization. So keeping this simple example, we can define our own words. And repeated units, suppose repeated units in polymeric chain, N represents repeated units, maybe 2, 4, 6, 8, 10, 100, 200, 2000, 3000, like this. The repeated units in polymeric chain are called degrees of freedomization. Degrees of freedomization. Functionality. If you observe functionality, first define in what is polymer. So the combination of smaller units results a lengthy or bulky product formation takes place. This lengthy bulky product is called polymer. This is called polymer. And the smaller units which involved in linking are called monomers. You need to write in your own words. Smaller units like ethylene units are called monomers. And converting monomers into polymer. Known as polymerization. This process is known as polymerization. The repeated units in polymeric chain, suppose N is equal 4 in polymeric chain. N is equal 4. Here polymeric chain N is equal 4 are there. N is equal 4. Each polymer consisting of how many carbons? 2 carbons are there. You can write chain line like this: C. 1 monomer, second monomer, third monomer, fourth monomer. Let assume it linking takes place between 4. Many are there. So, how many are there? N is equal 4, CH2, H2, each consisting of hydrogens, each carbon consisting of hydrogen. One monomer links with sidewise and is bifunctional in nature. This monomer combined with another monomer, one, and this also 1. So bifunctional in nature. It can form 2 links. So with sidewise monomer, another monomer in a closed system. Bifunctional. So consisting of 2 lone electrons, it can form 2 bonds, right? So how many are there? 1, 2, 3, like this. So a lengthy, bulky product is known as polymer, and the ethylene here, n number of ethylenes are called monomers. Converting monomer into polymer is known as polymerization. Each ethylene can form 2 bonds. Why does ethylene form 2 bonds? Because we can write skeletal structure of this. Switch. You will know why it is bifunctional in nature. So pi bond is a imaginary bonding. Just above room temperature, lone electron exists. Lone electron of pz electron. So this can pair up with another one. N number are there, and this lone electron also pair up with another. N number are there in a closed system. Under the condition of high pressure and temperature, when they come closer, they are capable of linking each other. Why do they capable of linking each other? Because lone electron, pi electrons. These pi electrons you can write like this. Pi electrons. Each monomer consisting of 2 lone electrons. Pi electrons. Above room temperature, no attraction exists. There will not be any attraction between lone electrons. When they are in attraction, it is called pi bond. So lone electron, it can link with 2. One sidewise monomer, this monomer. Bifunctional, it can form 2 links. It can bond with 2. So it is called bifunctional. So ethylene is having, each monomer is having 2 lone electrons. It can pair up with another monomer and link each other, known as functional. It is functional. So ethylene, as it consists 2 electrons, it can form 2 links. One, you can observe any monomer in polymeric chain. This monomer, you take this monomer, links with this and links with this. So which results a lengthy product formation. That lengthy product is called polymer, and monomers involved, the reactants, the small reactants involved in linking are known as monomers. Converting monomers into polymer is known as polymerization. Repeated units in polymeric chains. Let us assume chain consists 4. So 4 are there. So repeated units in polymeric chains, just for your clarification. So other n number is equal maybe 1000, 2000, 2 lakhs. Many are there. So repeated units in this called degrees of polymerization. Degree of polymerization. Right. Next topic, classification. Topic 1, types of polymerization or classification. Classification of polymers based on their skeletal structure. Based on their skeletal structure and monomers attached. Monomers are functional groups. Attached. Classified into 1. Homopolymer. Homopolymer further divided into homolinear polymer, linear polymer, homobranched. Right. 2. Copolymers. Copolymer. This also divided into 2. Co-linear polymer. 2. Co-branched polymer. Third one, graft polymer. First one, homolinear. So polymer example, this one, linear, identical. So ethylene monomers are there. Just like, instead of writing ethylene, I will write general example. It's M1 is called ethylene is called M1. M1. Just maybe 4, 1, 2, 3, 4, maybe 4, 8, maybe 8, 16, 1600, 6000. It may consist, polymeric chain may consist more than 2. Polymer consisting of 2 or more than 2, known as 2 or 3 or more than 3 is known as more than any bulky unit which consists lengthy unit which consists more than 3, known as polymer. If it consists only 2, dimer. If it consists only 3, trimer. If it consists more than 3, it is called polymer. Consisting of 4 or more than 4, maybe 8 lakhs, 8 crores, like that. So here is identical groups are there. This lengthy chain consisting of identical groups, identical monomers, ethylene monomers, linked with ethylene monomers. So where instead of ethylene, you can write a general formula. Ethylene is called M1. So this polymeric chain consisting of C monomers, and they are straight, linear. Therefore, it is called it is called linear polymer. So instead of here I wrote here, let me correct. I will write here like this. Homolinear polymer, homo, identical monomers, consisting of identical monomers. Polymeric chain consisting of identical monomers, and they are linear, straight, no branches, right? It is known as homolinear. Homo branched polymer. Branched polymer. Homo, and this polymeric chain also consisting of identical groups, but branches also there. M1, 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 like this, M1, M1. So on branch and main chain is made up of identical monomers with identical monomers. So monomers attached on branch same, and monomers on the backbone consisting of identical monomers only. So therefore it is called homo-branched polymer. Homo-branched polymer. 3. Co-linear polymer consisting of two different monomers. The polymeric chain consisting of two different polymers, different monomers, sorry. M1, M2, M1, M2, M1, M2, like this. So this polymeric lengthy product, bulky product is known as polymer. It consisting of monomers, different monomers, two different monomers are there, M1, M2, M1, M2, M1, M2, like this. This polymeric chain consisting of different monomers, and they are straight, no branches. It is called co-linear polymer. A lengthy product formed by the combination of two different monomers, known as co-linear, and it is linear, straight. Co-linear polymer. Co-branched polymer. Dash, 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 dash. So it consists, it's made up of two different monomers, and also consists branch. Therefore it is co-branched polymer. Co-branched polymer. Graft polymer. So I would like to ask you a question: what is the difference between graft polymer and co-branched polymer? Now, what is the difference between this polymer and this polymer, this polymer and this polymer? Here in homo branched polymer, both branch as well as main chain are consisting of same, identical. But here, this polymer, what is the difference between co-branched polymer and graft polymer? In this, branch consists M1, M2 monomers, and main chain also consists M1, M1. But here, main chain is made up of M1 only, but branch consisting of M2. And branch monomers different from monomers of main chain, backbone. This polymer is known as graft polymer. Just for your clarification, compare these two. Here you have branch consists M1, M2. Main chain also consists M1, M2. So total branch as well as main chain made up of different monomers, made up of M1, M2 monomers only. But here on branch monomers are only M1 on main chain, and the branch made up of M2 monomers only, M2 monomers. So this polymer is known as graft polymer. Mainly, fourth one, tactic polymers. Tactic polymers. So tactic polymers. So I will give one general example. Based on that, we can define. Further, it classified into 1. Syndiotic, syntactic. 2. Isotactic. 3. Atactic. Polymers. So mainly classified into 3. So for these 3, I will take one example. based on the function group attached to the chain different, it is called tactic polymer, which consists tactic polymers are the polymers consisting of functional group different same functional groups attached to the main chain different. So these polymers are called tactic polymers. Mainly three types: symbiotic, isotactic, atactic. So let me take one simple general example. C8 X4, I will write number of carbons C8. One, two, three. Otherwise, I will take C10. The carbon chain, the polymer chain, let us assume consisting of 10 carbons. 3, 4, 5, 6, 7, 8, 9, 10. So how many oxygen atoms attached? How many? So I will take 6 instead of 10. X remaining are hydrogens. H2 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 16 hydrogens are there, right? So functional groups attached to main chain are same side with respect to main chain. So 1 2 1 2 3 4 5 6 7 8 9 10. Here functional groups attached X. Second type. Third type, you can write hydrogens also. 1 2. How many hydrogens required? 2. It can expand up 4. It can form 4 links, any carbon, 4, either it may attach to hydrogens or X atoms or double bond or triple bond. There is no other atom. You can write it, maybe it consisting of unsaturation. Unsaturation because of attraction, unsaturation can be represented as pi bond or triple bond, double bond or triple bond, like this. So another structure, 3 4 5 6 7 8 9 10. 3 4 5 6. Here X atoms are same with respect to pi bond, known as symbiotic. In second case, X atoms or functional groups attached to the main chain alternatively. This side, next this side, next this side, next this side. How many are there? 3 4 5 6 X atoms. 16 hydrogens. You can write, you can attach hydrogens for second and third also. 1 2 3. First is known as symbiotic. So tactic polymer. Based on polymers, those functional groups attached to main chain are different. Polymers are called tactic polymers, mainly classified into 3 types: symbiotic, isotactic, atactic. If it is symbiotic polymer, functional groups, here functional groups are X, maybe halogens. X is called fluorine, chlorine, bromine, attached to the main chain or same side. 1 2 3 4, same side with respect to main chain. Known as symbiotic. Example 1. 2. Second, isotactic. Functional group attached alternatively. Here X atom is there, next atom, alternatively. So arrangement or attachment of functional groups are alternative with respect to main chain, known as isotactic. The last one, X atoms attached to the main chain are at random, irregular. Here, next here, no properly attached. They are irregular. The attachment of X atoms to the main chain are at random, known as atactic. So this all represented by same formula. This formula. Number of carbons 10, number of hydrogens 16. In this also we can write number of hydrogens also 16, and X atoms are all or attached to the main chain are 6 only, having same formula, same functional groups, exhibit different physical and chemical properties because of arrangement of X atoms are different with respect to main chain, known as tactic polymers. If the polymer consisting of functional groups same site with respect to main chain, it is called syntactic. If the polymer consisting of tactic polymer consisting of X atoms, functional groups, alternatively arrangement of X atoms alternative with respect to main chain, it is called isotactic. If the polymer consisting of X atoms, tactic polymer consisting of X atoms at random, attached at random with respect to main chain, it is called atactic, right? Next, classification. In this topic, on a last subtopic left, polymerization and mechanism of polymerization. In the syllabus, you have only two. One, condensation polymerization. Two, addition polymerization with mechanism. We need to discuss mechanism also. So in R22 syllabus, you have only two subtopics in polymerization. First one, condensation polymerization. So what is polymerization? We already discussed. The process of converting monomers into polymer is known as polymerization. So the polymerization in which liberation of water or acid takes place, the heavy lengthy product formed by the combination of monomers like this. During the process of converting monomers into polymer, liberation of water or HCl acid takes place. That polymerization is known as condensation polymerization. Best example, condensation polymerization. Example, I will take example only, nylon 66. So this lengthy product formed by the two different monomers. During the process of linking, liberation of water takes place. So this is formed by the two different monomers. One. So I will write only IUPAC. If I mention common name, you will be unable to write skeletal structure. So you need to remember while practicing, you need to write on the white paper. Practice is very important as far as concerned to organic chemistry or polymers. So polymers is part of organic chemistry. So you need to write, you need to practice writing only. No, if you read, you cannot recollect. So writing practice is very important. So this condensation polymerization, best example, formation of nylon 66. Nylon 66 is formed by the combination of two different. I will mention only IUPAC nomenclature, so that you will be able to write its structure easily without practicing also. Just you need to remember only names of monomers involved in polymerization, in formation of nylon. 1,6-hexane, normal hexane, okay. Instead of this here you have dioic acid, hexane, 1,6-hexane dioic acid, and hexane, normal hexane, CCCCC 8 carbons with saturation, no double bond, no triple bond. Hexane, instead of normal hexane, here you have instead of E, you have instead of this E, you have diamine, 1,6-diamine. It's very easy. You need to remember only these two. Hex, root word is hex. It means Main chain consisting of how many carbons? 6 carbons. You need to write 6. 3, 4, 5, 6, right? So oic acid is there on first carbon as well as 1, 2, 3, 4, 5, 6 on first carbon as well as on last carbon, terminal carbons. Oic means you need to write O H like this. C double bond O, you can write clearly. C double bond O and COH. COH. This you need to write clearly. You will understand easily how do they combine. During combination, removal of water, how does removal of water takes place, you will understand easily. So first carbon COOH, remaining are hydrogens. You know very well, carbon cannot in any polymeric chain, carbon, all polymeric chains, all natural products, all bodies of living, whether living or non-living, consisting of polymer, backbone, main chain consisting of carbons only with covalent bond. So carbon can form how many bonds? 4. As it belongs to fourth group, it can having 4 lone electrons in excited state. They can link, they can pair, and linking takes place. Formation of bulky, a lengthy product, polymer takes place. So any polymeric chain, it can form 4 bonds. It cannot expand more than 4. It cannot expand its covalency more than 4. 4 bonds. So already 2, 3, 4 are there. No vacant electron. 2. How many hydrogens? 2 hydrogens. 2. It can link with 2 hydrogens. 1, 2, 3, 4. 1, 2. 1 bond with this, 1 bond this, still 2 electrons left, 2 electrons combined, attached with 2 hydrogens. This is the structure. Dioic acid place. So it's a polymer. You need to take N number. So another is hexane diamine. NH2s are there on first carbon as well as this chain consisting of 6 carbons. First carbon attached with amine. Second, last carbon also attached with amine. So hex 1, 2, 3, 4, 5, 6. You can write number also. 3, 4. From you can start giving number from either right side or left side. Amine attached. NH. Here also NH. How many are there? A number. You can write number of hydrogens. 1, 2. How many hydrogens? 2 hydrogens. 1, 2. So 100% confirm. So it can form 4 bonds, either with sidewise carbons or double bond or triple bond, or if there is no electron, no other atoms, double bond, maybe double bond or triple bond, or remaining are hydrogens. 2, 1, 2, still 2 low electrons there. It can attach with 2 hydrogens. 1, 2. CH2. Already there hexane. If it is normal hexane, only hydrogens, no double bond. If it is hexene, double bond is there. If it is hexine, triple bond is there. Instead of E area substituted by amines. How many amines? 2. On attached on which carbons? First carbon and 6th carbon. Right? Already they are keeping this name in mind. You write skeletal structure for that. So this N number are there. N number in a closed condition. This OH, H plus, OH minus, it links with another. This links with another. Links with and N number are there. So linking takes place between 2 different monomers: amine, diamine, and dioic acid. Dioic acid, diamine. So linking takes place. So N number are there, right? So H plus, removal of H plus and removal of OH minus ions, right? Like this. So bond formed, you need to write as it is, no problem. Linking, you put star for your clarification. Linking. So as it is, you can write as it is, no change. You just remove OH because it attached to diamine. Monomer, another monomer of different monomer, which is different, this diamine. This attaches to another, here I am showing, attach this. What about this? N number are there, attaches with another own dioic acid, right? You need to write as it is. How many are there total? CO attachment is there, OH minus is removed, OH minus and H plus ends, minus HOH. How many are there? N into N, 2N minus HOH, 2N HOH. See how many methyl groups are there? 1, 2, 3, 4 repeated units. CH2, 4, CO, OH is removed and H plus also removed. OH and H plus. Right. How many are there? N, 2N, 2A, HOH. This links with this amine group, NH. So already I put, for your clarification, I put star group, it links N and CO. CO is dioic acid of C, last carbon, and last amine group. NH, CO, removal of OH minus, removal of H plus. CO, NH, CO, NH. So, star is there, here also star is there. New link. How many methyl groups are there? Repeated 2, 3, 4, 5. 6. 6 are there. CH2 and H plus is removed, OH minus is removed. N number are there. We don't know N number. It may be 4, it may be 8, it may be 800, it may be 8 lakhs. N is equal, we don't know. Right? So in these repeated units, this bond is called peptide bond. Bond formed between own and amine is known as peptide bond. Bodies of all living natural creation on the earth surface. Bodies of living organisms made up of peptide bond is mainly composed of polymer, hydrocarbons and proteins and lipids made up of peptide bond. Peptide bond and this one is bond between own and amine of chain, polymeric chain is known as peptide bond. Next, addition polymerization. In condensation polymerization, the polymerization in which removal of water or acid takes place is known as condensation polymerization. In condensation polymerization, this will come under best example for copolymer. Different monomers are there and heavy monomers, dioic acid and diamine. So different monomers involved in combination. Removal of water takes place, known as condensation polymerization. So for this you have no mechanism, but you have mechanism for addition polymerization. You can take simple example, addition polymerization. On the topic 1, we're discussing about addition polymerization. Same example we mentioned in the beginning. So N number of CH2 combine each other, convert into CH2 ethylene monomers, formation of polythene, you can represented by P. So here no side product, therefore no side product, no waste product. Therefore, gram molecular weight of this lengthy bulky unit equal to the sum of the gram molecular weights of sum of the monomers involved in polymerization. So this polymerization is called addition polymerization. So no side product in this polymer. First point, no side product. Only addition. N is equal to maybe 2000, maybe 4000. If the bulky product, a lengthy product called polymer formed by the linking of 1000 monomers, 1000 ethyl monomers. So gram molecule of this lengthy product equal to the gram molecular radius of some of the monomers involved, because no waste product, no side product, right? So no elimination, only adding. This type of polymerization is known as addition polymerization. Addition polymerization, you can write in your own words. You can take any example, maybe polythene, maybe PVC, maybe polystyrene. You can take an example, maybe Teflon. Same skeletal structure for remaining three also. So instead of, if it is PVC, instead of one of the hydrogens substituted by Cl, n number of CH2 CHCl undergo double bond is there. CH2 CH double bond disappears. This is called PVC. Vinyl chloride. Common name of this is vinyl chloride. N number of vinyl chloride undergo polymerization, formation of polyvinyl chloride. In this also skeletal structure same. PS also skeletal structure same. Teflon also skeletal structure same. How does this pi bond disappear after polymerization, after linking? Very simple. You need to write skeletal structure. How many are there? Whether it is HS, how many to attach it? Two bonds, two bundles. N number are there. 1, 2, 3. Low neutron. PZ low neutron. If attraction is there, it is called pi bond. Just above room temperature, attraction does not exist. Low neutron. So it is bifunctional. Already we discussed it. If monomer consists 2 low neutrons, it can pair up with sidewise monomer, another monomer in closed container. When you compress, they come closer, they pair up each other. Where does it pair up? This low neutron combined with another monomer. So bifunctional, it can link, it can form two bonds. It is known as bifunctional. So all consisting of same skeletal structure. If it is polythene, consisting of only hydrogen. If it is polyvinyl chloride, consisting of one of the hydrogens attached with Cl, remaining are hydrogen. If it is polystyrene, one of the hydrogens substituted by what? C6H5. If it is Teflon, all hydrogens replaced by what? F. No change in double bond. To low neutron, just room temperature, it is pi bond, like this. Above room temperature, excited state, each carbon consisting of PZ low neutron. If some attraction prevails, we assume that attraction we give a name, that is pi overlapping, pi imaginary overlapping, right? Like this. Need to write almost all addition polymerization takes place in presence of peroxide. So in the syllabus we have free radical addition polymerization mechanisms many are there. Cationic addition polymerization, free radical addition polymerization, but in the syllabus we have only free radical addition polymerization. Free radical mechanism free radical addition polymerization. So polymerization, addition polymerization, only adding, no elimination. Therefore this equal to sum of the monomers involved is known as addition polymerization. Free radical addition polymerization, intermediate products are free radicals. So here completes in 3 steps. Chain initiation, this free radical addition completes in 3 steps. 2, chain propagation. 3, chain termination. First one, so all addition polymerization takes place in presence of peroxides. So first chain initiation. So peroxide, I will take It may be R is equal to benzyl peroxide, or hydrogen peroxide, or acetyl peroxide. Many are there. R stands for benzyl C6H5 or CS3 COO or H. Hydrogen peroxide, maybe I don't know, as RCO CO R in presence of UV light undergoes homolytic fission. Homolytic fission, breaking. Fission means breaking in presence of UV light. Why does it undergo homolytic fission? Same atoms attached. So easily bond, number of electrons involved 2. Any bond, number of electrons. So since they are identical, same, they are bonded pair very localized between two atoms at same distance. So while breaking, electron this equally sharing, distribution while breaking. So formation of free radical takes place. R CO O dot means this electron, and 2 electrons are there. Let me bond electron equally distribution while breaking, because same bond. So homolytic fission. In heterolytic fission, NaCl is there, 2 different atoms is there, therefore Cl is more electronegative, bonded pair very close. This undergoes, of course, Na also involved in bond, lone electron, Na electron and Cl electron, 2 electrons are there. To this bonded pair electron very close to the chlorine. So while breaking, it unequal breaking takes place because their electronegativity difference is there. Bonded pair very close to the Cl atom. While breaking, it undergoes heterolytic fission. You will get ions, Na plus and Cl minus ions. In heterolytic fissions, result of products are ions. In homolytic fission, you will get free radicals. Plus, how many are there? R COO dot 2 are there. Right? This still undergoes, this also breaks homolytically, or it may be methyl group, acetyl chloride, acetyl peroxide, CS3 CS3. Here also bond formed between CC, identical atoms. In presence of UV light easily undergoes homolytic fission only. Instead of methyl here or alkyl group, any alkyl group. So you will get, how many are there? 2 R. How many COs? When it breaks homolytically, electron distribution take equally. This electron minus, already pi bond is there. 1 pi bond is there. Second new pi bond. This lone electron becomes new pi bond. See, we don't need to discuss in detail. Just for your clarification, how lone electrons become 5 bond. Like this. Lone electron. How does it get lone electron? During the process of homolytic fission, distribution electrons involved contributed equally, and while breaking also equal distribution will be there. Lone electron, or this is lone electron of this carbon. Lone electron is a pi bond, new pi bond, right? So this once free radical is formed, it will attack on n number of monomers. R attacks on CH2. So just now we discussed just above room temperature. How do they exist? Just above room temperature, just I mentioned in the previous example, lone electron like this. just when it attacks this angle, how does it attacks CH2 just above room temperature, no pi bond exists, low neutron, low neutron. Low electron of this low neutron, pairing takes place, links with this carbon. If it links with this carbon, so you will get another free radical. So after linking with this carbon, why does this R free radical links with this? Low electron of this and low neutron of this. To these two electrons, when they are in attraction, it is called pi bond. It is called pi bond. Though there is no attraction, above room temperature, in excited state, it consists only low neutron. You cannot imagine some attraction is there. That name given for that attraction is pi bond. So above room temperature, they are in excited state. Excited state each consists one pz low neutron. It can bifunctional in nature. It can form two links. If the R free radical attaches this, you will get another free radicals. So this links with this only. So after linking, low neutron left on this carbon, it is called another free radical. Another free radical or CH2 dot. This attacks on another monomer CH2 links with this or CH2 right. This attack done and another, you need to write, you don't need to write same units, n number, you can take n number. So in the chain, how many are there total? Already 4 are there, 2 monomers are there, another monomer, 3 monomers, each monomer consists how many carbons? 2 carbons. You can write faster. Chain consisting of, along with in addition to free radical are 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, each monomer with 2 carbons. 1, 2, 3, right. CH2. It may attach, meaning n is equal maybe 8, maybe 16. You can put like this, right? So like this. So n number are there, you can mention somewhere between n for just balancing, right? Like this. So in chain initiation, this is called chain initiation, this is called chain propagation. In chain initiation, only free radical formation takes place. Free radicals are highly unstable, just like ions. So in the closed container, under conditions of high pressure and temperature, in presence of all reactions take place in UV light only, UV light. Initially, homolytic fission takes place. Peroxide undergo homolytic fission. Why do they undergo homolytic fission? I already explained. So free radicals form. Once free radicals formed, they will attack on monomers in the closed system. So in chain propagation, chain length increases. One free radical attacks on monomer. Here reactants are one monomer, another free radical. In chain initiation, you will get only free radicals. In chain propagation, you will get chain free radical combination takes place between free radical and monomer. Free radical and monomer. Free radical, a lengthy free radical. It is lengthy free radical. This attaches with this carbon. So you will get this. Pi bond out of pi, one electron involved in linking with this. Pairing takes place, new bond. So next free one electron left on this, like this. So n number add increases, n number increases like this. So chain length increases. In second step, one free radical attacks on monomer. So chain length increases. It is called chain propagation. Last step, you stop supplying UV light. If you want to stop a chain length, if you don't want to increase chain length, just stop supplying UV light. In absence of UV light, all free radical will get combined. R dot plus R dot, R. This is called X dot. Or you can write instead of X, you can write just for your practicing. How many are there? 1, 2, 3 monomers are there. You can write 3 monomers. All free radicals combine in chain propagation. Or 3, 4, 5, 6 dot H2, 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 H2 combine with, you can write this side for your understanding, 3, 4, 5, 6 are CH2, 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 CH2. They combine each other. You will get lengthy product or CH2. How many are there? 1, 2, 3, 4, 6, 12 plus R length product. In chain termination, chain growth stops. Chain growth stops. Why does chain growth stops? Two free radicals get combined. Why do they combine? In absence of UV light, no sufficient energy. Free radicals left in the closed system, they combine each other and chain growth stops. This is known as chain termination. Chain initiation, chain propagation. In chain propagation, one free radical attacks another monomer. In chain termination, two free radicals combine. Here, one free radical and one monomer. One free radical, monomer. One free radical, lengthy free radical and monomer combine each other. Here, reactants are the monomers they combine are free radicals. Only free radicals combine. So all free radicals disappear once they combine. In absence of UV light, chain will get terminated. Chain growth stops, known as chain termination. Chain termination. First one, chain initiation. Second one, chain propagation. Third one, chain termination. With this, I conclude. In the next class, we'll discuss. So, next topic. In the polymers, unit 4, next topic, thermoplastics and thermosetting resins. So, preparation properties and uses of PVC, Teflon, bakelite, nylon 6s. These are the topics we are going to discuss in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.